Welcome back to my YouTube channel, ladies and gentlemen. On this video, I'm going to be covering the very second last topic of HCAI Datacom. A big congratulations to you if you've been able to come this far. This is a very interesting topic by the name of network programmability and automation. This is one of the trending network engineering skill that is most sought after. So I would encourage you to take this up, especially on HCIP, because here it's only but an introduction. But we have HCIP Datacom network automation. So it's the one that dives deep into Python programming and how to automate networks. Okay, so ladies and gentlemen, the forward, new protocols, technologies, and delivery and O&M modes are emerging in the network engineering field. Conventional networks face challenges from new connection requirements, such as requirements for cloud computing and artificial intelligence, AI. Enterprises are also pursuing service agility, flexibility, and elasticity. Against this backdrop, network automation becomes increasingly important. Network programmability and automation is to simplify network configuration. Is really used to simplify network configuration, management, monitoring, and operations for engineers and improve deployment and O&M efficiency. So this course is going to help network engineers understand Python programming a little bit and implement network automation. By the end of this chapter, you should be able to describe the difficulties of conventional network O&M, understand the implementation of network automation, understand the classification of programming languages, describe the Python code style, and also be able to describe the basic usage of Python telnet lib, a library that is used for network automation. Okay, so let's begin by looking at an introduction to network programmability and automation. We begin by looking at the difficulties that you experience in managing or running the conventional network O&M. Now, conventional network O&M requires engineers to manually log into the devices, then query those devices and execute configuration commands, and thereafter filter command output. We know that we do this using protocols such as Telnet, SNMP, and others. So this is a highly human-dependent working mode, which is time-consuming, inefficient, and difficult to audit. Why? Because imagine you need to do device upgrade, and your network has thousands of devices, live devices. So how are you going to be able to do this upgrade? Because generally with networks, due to service requirement, most of the time you'll need to upgrade it regularly. So you have to do it manually, and that is quite time consuming and cumbersome. Also, configuration audit. An enterprise needs to audit the configuration of devices every year. So for example, the enterprise may require that the telnet, secure telnet, be enabled on all devices, and STP, for example, security, is also enabled on Ethernet switches. So in this case, you have to quickly find out the devices that do not meet these particular requirements, devices that do not support, for example, STP security or secure telnet. So that is what we call configuration audit. So that's another task that is common on networks. And lastly, you might also need to do configuration change. One of the regular configuration change that is made on networks is the details about device accounts and passwords. So for example, you might have a policy that requires you to change the passwords after every 3 months. So you have to do this after every 3 months. You have to perform this particular operation. So again, this is quite a task because you have numerous devices. You have to remember the complex commands and to be able to do either the audit or the configuration change. And as you can already guess, this is going to take a lot of time and might also interrupt the network services. So this is how we do it. You have you as the network admin here, and you have to log into each of these. You have to log in into each of this device and configure them one by one. So as the number of devices increase on your network, then also your task, your workload also increases exponentially. Now, that is why we need network automation. Network automation. These are tools. Tools are used to implement automated network deployment, operations, and O&M, thereby gradually reducing dependency on human. So this will solve the preceding problems that we discussed. Now we have many open source tools that are used. Open source meaning you can be able to download and use it. We have many open source tools that can be used to automate networks. One of them is called Chef. As you can see here, we have Chef, we have Ansible, we have NMS tools, we have SaltStack, we have automated scripts, we have another one called Shell, and this particular unit is going to be focusing on how to use a programming language called Python to automate networks. Okay, so programming-based network automation. In the recent years, with the emergence of network automation technologies, Python-based programming capabilities have become a new skill requirement for network engineers. So for network engineers who are escaping from programming, welcome back. You now have to learn programming, and specifically you have to learn Python. So automation scripts are written in Python and they can be executed repeatedly using what we call rule-based operations. So for example, this is just an example of a Python file. This is an example of a Python file, as you can see here. So we've written some configuration commands. So you can see here, for example, we are writing the command to change the name of the switch. Then we are creating VLAN 10. Then we are putting some description for VLAN 10. Then we are creating VLAN 20. Then we enter some description for VLAN 20. Then we create VLAN 30, like that. So we normally write a Python file, then we execute this particular Python file on the network device, and we can be able to do that from our network management system NMS by using either SSH or Telnet. So this particular example is what I have just taken you through. That is what we're having here. Okay, so now let's have an overview of programming languages and Python to be particular. Okay, so a programming language is used to write a computer program. The computer program will control the behavior of the computer. So that is what a computer program is used to do. Now, according to whether compilation is required before execution of a language. The programming language may be classified into number one, compiled language, and number two, interpreted language. Now, what is compilation? Compilation is converting a program really from high level language to low level language that is understandable by the machine. So that is what we call compilation. Now generally let me, okay, just a moment. Okay, my scroll is misbehaving. So generally computer languages can be classified as either high level languages. Number two, we have what we call assembly language, and lastly we have machine language. So when you talk about high level languages, these are languages that are human readable. They are written in English-like statements. So normally what you call the source code, that program that you write using, for example, Python, is a high level language. Now computers cannot be able to execute that particular program the way you have written it, and that's why it needs to go through a compiler. When it goes through a compiler, then it becomes an executable file, and that particular file actually has zeros and ones that your machine now can be able to understand. Those zeros and ones is what we call machine language. And of course at the middle here we have the assembly language, which is still English-like but closer to machine language. Closer to machine language in the fact that here it is not very abstract. It's not very abstract like the high level languages. So we have another language in the middle there that is called assembly language. Now let's go back to the initial discussion. So we were saying if a program needs to be compiled before it runs, then it's called a compiled language. It's called a compiled language. Okay, sorry about that. It's called a compiled language. Now with a compiled language, it has to go through the compiler, then becomes an executable file, and therefore now the operating system can be able to host it. That is, you can be able to install now this, for example, into the operating system, and you can be able to execute that particular file on your CPU, whether it is the x86 architecture or ARM CPU architecture. On the other hand, we have interpreted languages. Now with interpreted languages, you don't have to compile it. You don't have to compile it for it to run on your computer. What happens is that with interpreted languages, we have what we call the interpreter. The interpreter really interprets the source code line by line. So it interprets the source code line by line and executes it depending on the particular instruction that has been given. Now generally examples of, for example, compiled languages, we have C, we have C++, and others. And then for interpreted languages, we have languages like Java, Python, PHP. All those are really interpreted languages. Okay, so here we have what we call the computing stack, and the program execution process. So this is the computing stack. You can just think of it as the layers of a computer. So we have, as you can see at the middle here, you can see we have the, sorry, not there really, but here. here you can see that we have the hardware. So the hardware, on the hardware we have on your CPU we have a micro architecture. We might be using the ARM architecture or the x86 architecture. Then on your CPU we have the gates and registers, which are the ones that are electronic transistors that are used to do computations using transistors, and now the physics behind it, that is electricity, that is able to do the calculation. So that is the hardware. Now on this particular level of the hardware level, the only language that the computer understands is the machine code. And the machine code, as I said earlier, is in zeros and ones. In zeros and ones. So your hardware can only be able to execute zeros and ones. Okay, then we have the upper stack. The upper stack, where now we have the software. So here you have your application. Your application is written using algorithms in order to perform certain actions, and it's written in a high level language. It has to be translated to assembly language, then to machine code, before it is able to be executed on the CPU. So generally that is a computing stack. On the other hand, when it comes to the program execution process here, so you write your program in using a high level programming language. So for example, this is how we declare variables. For example, temp is equals to this, like that. So it's going to be translated into assembly language, as you can see here. It's going to be translated into assembly language. Then after that, it's going to be translated to machine code, to zeros and ones. So that's how it flows from high level to assembly, then from assembly to machine code. And from machine code, now we have an instruction set. Instruction set is really what is going, the action, the task that is going to be performed by that particular program. Okay. So high level programming languages, we want to look at compiled languages. So here, as we said, before a program in a compiled language is executed, compilation process is performed to compile the program into machine language. So the compilation results can be directly used without retranslation during running. So what that means is that once you've compiled your program, then we don't have to retranslate it. The computer can be able to execute it because the compiled program is already in zeros and ones. So typical compiled languages include C, C++, Go, etc., etc. So here you begin from the source code. The source code will go through a compiler. So the compiler will convert it to assembly language. Then the assembly language will go through an assembler. The assembler will convert it to an object module, which is a machine language module. After that, normally many languages have what we call library function. That is, they come with what we call default functions, if you can allow me to use that name. Functions that will allow you to perform certain tasks, like function that will allow you to do input, to do output, to calculate the square root, for example, of a number. So you don't have to write a program to calculate the square root. You simply call that function. So that is what we call the library function. Functions for time, etc. So your program, your object module, is going to be linked up with the library function. That is done by using the linker, and the linker will now generate what we call the executable code, which is in machine language. Now that is going to be loaded by the loader to the memory and be executed. So generally that is how your compiled language is processed on a computer. On the other hand, what is the difference between that then and interpreted languages? Interpreted language programs do not need to be compiled before running. So they are translated line by line when running. Line by line, very important. They are translated line by line when running. So typically, languages such as Java and Python are interpreted languages. So the process from the source code to the programs, so the source code of an interpreted language is generated by the compiler. So you can see we have the Java language program, which is now the source code. So it's going to go through the compiler, and the compiler is going to produce what we call a bytecode. A bytecode. Now, this bytecode is going to be executed by a VM, what we call a virtual machine. For example, for Java, that virtual machine is called JVM, or Java Virtual Machine. So the Java Virtual Machine is the one that runs the bytecode. And of course, just like in the previous one, we also have library functions that come with, for example, Java. Similarly, for example, with Python, because it's an interpreted language, it simply goes through the compiler. You can think of the compiler here as the interpreter, really, as the interpreter. Then that is converted from your program to a bytecode and finally runs on the PVM. So PVM is Python Virtual Machine. So what is Python? Python is a fully open source, high-level programming language. Some of the advantages of Python: number one, it is dynamically typed with elegant syntax. So it allows learners to focus on the program logic rather than syntax detail learning. So what this means, number one, is that it's easy to learn because the syntax is not very complicated. What is a dynamically typed language? Now, generally, any programming language will allow you to create variables. Variables are used to store different types of data on your program. For example, you can create a variable to store the first name or a variable to store the second name. Now, for example, in C, if you want to create a variable, for example, to store the first name, you have to specify the data type. For example, a string. So that is in C++. So string, then the name of the variable. For example, first name, like that. So you have to do that. But so with such languages, we call them statically typed. Why? Because with this kind of language, you have to specify the data type when you're declaring the variable. You have to specify the data type, string. So for example, again, you want to declare a variable to hold age, so int for integer, int age, like that. So you have to do that. But for dynamically typed languages, you don't need to specify the data type. You simply declare the variable, and the computer itself will, the language itself will determine the type of data that you've stored in that particular variable. So that is what we call dynamically typed language. And that makes some languages easier to use when they're dynamically typed, because you don't have to stress. Because you can, for example, even though you've called this age, you can be able to store even a character inside that variable. Okay. So the other advantage of Python, it supports both procedural and object-oriented programming. So these are two different programming paradigms. One uses statements and functions, the other one uses classes. Object-oriented programming uses classes. So it supports both of them, Then it also provides a good number of third-party libraries. Like one of the library we're going to look at is called telnet nib, that it will allow you to telnet into a device and be able to configure it using Python. So it allows so many third-party libraries, and it's also nicknamed the glue language. The glue language. Reason being, it can talk to code written in other languages. So it can be able to talk to code that are written in other languages. So that's another big advantage of Python. You should learn Python not just because of network automation, but Python is also the main language that is used in AI, data science, that is data analytics, and also scripts for automated O&M. That is why you're learning it right now. One of the disadvantages of not just Python but interpreted languages is that interpreted languages run a little bit slow compared to compiled languages. Remember, we said compiled languages, when they are compiled, they are saved as machine code, and therefore the computer doesn't need to reinterpret it. It can just run it. Can just run it on the go. But when it comes to Python and other interpreted languages, the computer has to translate the code line by line into machine code, and this is time consuming. So that's why interpreted languages run a little bit slower compared to their counterpart, compiled languages. So the Python code execution process, as we said, you begin by the source code. Source code is what you've written in the high-level language. It goes through the interpreter. We form the bytecode, and finally it's executed. It's executed on the Python virtual machine. So the Python VM converts the bytecode into machine language. Then the hardware executes the machine language. Normally, the Python bytecode will have the extension .pyc. So Python can run in one of two ways. The first one is called interactive running. And the second one is called script. In one of two modes. The second one is called script mode. So we have interactive mode and script mode. Interactive programming does not require the script file to be created. So the code is written in the interactive mode of the Python interpreter. So what that means is this. For example, on the command prompt of your Windows operating system, if you open the command prompt and you've installed Python, you can type Python. Then after that, you can be able to execute Python code. So for example, after typing Python, you're going to get this particular prompt. If you type this, print hello world, then you press enter, it's going to print hello world. You declare a variable like this, you declare another variable and assign it the value 2, then you say print a plus b, it's gonna print 3. So that is what we call interactive mode. So you're running the code not from a file, but as you type, things are happening. So that is what we call interactive mode. Now, the second way in which you can execute Python is script-based running. So in script-based running, you have to create a file. That file is saved with the extension .py. So for example, here we have the file demo.py. The first statement on the file, print hello world. The second statement, we declare a variable a, assign it the value 1. we declare a variable b, assign it the value of 2. Then we print a plus b. So how do you execute this particular file that has been written in Python and saved with the .y? So if you've installed Python in your machine, you go into the command prompt, for example, you type Python, then the name of the file dot the extension of the file, and it's going to execute that particular Python file. So it's going to print hello world, then print 3. So that is what we call script mode. So you can run Python in one of those two ways, interactive mode or script mode if you're executing a file. Okay, so let's learn some basics. Let's learn some basics about the style of writing Python code. So code style rules. So code style rules refer to naming rules, code indentation, code and statement segmentation modes that must be complied with when Python is used to write code. So the good styles rules help improve code readability and also facilitate code maintenance and modification. So we have some rules here. For example, this one is for how and when to use the semicolon. Unlike C and C++, you don't have to terminate every statement in Python with a semicolon. You don't have to do that. However, it is recommended that each sentence or statement be in a separate line. So for example, you've seen earlier that we declared A, assigned it to 1. So if we want to declare B, we have to write it on the next line, on a separate line. B is equals to 1, to 2, for example. So again, we don't have to use semicolon to terminate every statement, but every statement should begin from a new line. So that is what we call a statement. So this is one statement, this is another statement. Some literature also call it a sentence. Okay, then we have blank line. So different functions or statement blocks can be separated by spaces. So a blank line helps differentiate two segments of code, improving code readability. So what is a blank line? So for example, we've declared A and B, then we want to print A plus B. So we can do that, print like that, A plus B, A plus B, like that. So if we want to maybe declare D and C, we can separate using a blank line like that, and now say C is equals to maybe 5, then maybe D is equals to maybe 10, like that. So really what you're trying to say here is that you can use what you're calling blank line, this one here. You can use this blank line here to separate different parts of the code. Why? We just want to improve the readability. Why is readability important? It helps during code maintenance and code modification. And so you can separate using a blank line. Then parentheses. So parentheses are simply brackets. Parentheses can be used for the continuation of long statements. Please go and read more about that when you have time. Then we have space. This is the other important one. Spaces are not recommended in parentheses, but you can determine whether to add spaces on both ends of a particular operator. So also read more about that, but we're also going to see about code indentation. Okay, so we want to see how do we name identifiers in Python. So an identifier in programming is simply a name. The name can be used to name what you call a constant, a variable, a function, a class, etc., etc. So user-defined names. Now normally we have rules for writing these names that are called identifiers. For example, they can contain letters, they can contain digits, they can contain underscores, but they might not contain any other special character other than an underscore. So that is one of them. You cannot also have spaces. Between these particular names. For example, here we have a variable name user underscore ID. So whenever you think your name is made up of more than one name, then you join them using an underscore. So you cannot have white spaces for a name. It has to be one word. Then also it cannot start with a digit. So you cannot start your identifier, your variable name, with a digit, like 4 underscore password. That is incorrect. Identifier. Identifiers are also case sensitive and must be unique. Case sensitive, don't forget, case sensitive. So here user ID and user ID are two different identifiers. They are two different identifiers because this one has uppercase U, uppercase I and D. This one everything lowercase. So these are two different. Why? Because they are case sensitive. The other thing is that it has to be unique. So you can't have the same identifier declared more than once. And if an identifier does not comply with the rules, the compiler will generate a syntax error. It will generate a syntax error. Then we have the print function. The print function is a built-in function of Python and is used for output of content, the content that is in the parentheses, the output of content that is in the parentheses. So you can see, for example, here we have print user ID, print user ID, print username, print count, print this one, like that. So we have all those. So what will be the output? What will be the output of this particular program? What will be the output of this particular program? The output will be, of course, for this first variable user ID, we assigned it to 10, so it's going to print 10. Then for the second one, it's going to print 20. Then it's going to print, as you guessed it, Richard. Then it's going to print count is equals to 1 plus 1, so it's going to print 2, like that. Then for this one, it's going to print syntax error, because it's an error. The variable here is wrong. It's going to print syntax error because this variable is wrong. So that's going to be the output of this particular program. Okay. So another important concept in Python is the concept of code indentation. So code indentation represents the scope of a code block. Concentrate a little bit more here, because unlike in languages like C and C++, where we do code indentation just for readability, here code indentation is part of the syntax, because code indentation is used to identify a block of code. So if a block of code contains 2 or more statements, the statements must have the same indentation. It must have the same indentation. So for Python, code indentation is a syntax rule. So it's a syntax rule. It's not just a thing that is used for readability. It's a syntax rule that uses code indentation and colons to distinguish between layers of code. So when writing code, you are advised to use 4 spaces for indentation. If incorrect indentation is used in the program, then an indentation error message is displayed during the code running. So you should always use the correct indentation. So this is a good example. So we have, for example, the if statement here. If true, then whatever comes inside it, you see it has been indented by 4 spaces. That's why it's starting inside there. Then else, then again we indent this like that. Then we separate with the white because we are starting something different. We separate with a white space, then we start something different. So you see here we are declaring A is equals to Python like that. Now we've done a mistake here because we want to print A, but we've indented print, and that should not happen because print should be on the same level as the declaration of A. So it should start from the beginning here. So this is an example of incorrect indentation. So you should only indent, especially when you are defining a block of code, because as we know, for example, in C and in C++, we normally use, for example, so this is the condition. Then we have, let me do that. We have an opening curly bracket. Then, for example, you indent, you have some statement like that. Then you have that. So in C++, the curly brackets are used to define a block, but here the indentation defines a block in Python. So it's part of the syntax and not just code readability. Okay, then using comments, just like in any other programming language, we have 2 types of comments in Python: single line comments and multi-line. Single line done using a hashtag, multi-line done using triple quotes. You can see if you want to do a single line comment, here, hashtag assign a string to A. Comments are important. They're very important because they help you to remember the different parts of your program when you want to maintain or update the code. They also help others that did not write that particular program to be able to have an easy time to go through the program, learn it, and also be able to maintain or update it. So for multi-line, you do the triple quotes, double quotes, then again you do some comments in between, then you end it again with triple double quotes like that. Okay. So the source code file structure, how does it look like? A complete Python source code file generally consists of interpreter, encoding format and encoding format declaration. Then you have the document string, then you have the module import and the running code. So those are the things that must be there on any source code file. So this is the interpreter here. This is how we do the interpreter declaration. The interpreter declaration generally is used to tell us where the interpreter has been installed, the location where the interpreter has been installed. So here it has been installed under the user bin, and then environment, then Python. So under this folder, user bin env, like that. Okay, then the next one is encoding format. Encoding format, as you can see here, this one, for example, is using UTF-8. So we have several encoding formats. We normally have UTF-8, we have ASCII code. So for example, for Python version 2, it supports only ASCII code. For Python 3, Python 3 supports both ASCII and UTF-8. Why is UTF-8 important? UTF-8 supports Chinese language, but ASCII does not support Chinese language, for example. Okay, then we have the description, the code description. So this particular description is used to tell us about the program. What does the program do? So to describe the function of the program. So it's just like a comment, just like a comment. This document is intended for blah blah blah. Then other than that, we can have the import, the module import. So we can be able to import several modules. How to do that is we type the word import, then the name of that particular module. So for example, import time is gonna import functions that are used for processing time, functions that are used for processing time, so that we just call those functions. Then of course after that, we now have the code that you're writing, the code that you're writing, the source code that you're writing to solve a particular problem. Okay, so what is the difference between a Python function and a Python module? So a function is a block of organized, reusable code that is used to perform a single or related action. A single or related action. So it can improve the modularity of the program and code utilization. The function is defined using the def keyword. The def keyword. So let's see an example. So here you see we have def. We have def. Then the name of the function, sit. Then a function normally has a parenthesis, the brackets. So that is how we define a function. Then after that, we can indent the code that we want to be inside that particular function. So for example, we've indented this, print, a dog is now sitting. So normally you can call a function. How do you call a function? By typing its name and the parenthesis. So that's what we call a function call. So anytime you call a function, then that function, the code that is inside that function is going to be executed. So you call sit, it's going to print this. A dog is now sitting. If you call it again, it's going to print it again. So that's why we say that a function is reusable. It is reusable. It can improve modularity and code utilization because you can reuse the code many times. So that is what we call a function. Now, what is a module? A module is a saved Python file. So a module can contain definitions of functions, classes, and variables that can be utilized in other programs. So the only difference between a module and a regular Python program is that it is used for importing by other programs. So that means that a module will not have what we call the main function. What we call the main function. So normally, just like in C, C++, the flow of the execution of the program begins from the main function. The main function is the function that the compiler will look for and call automatically when you start executing that particular program. So we only have one main function in any computer program, only one. So any other file that has other user-defined functions, variables, classes, and does not have the main function is what we call a module. Is what we call a module. So for example, here we are creating a Python file called test.py. Test.py. Then we are importing we are importing a module. So import demo. So remember, this demo is just another Python file, particularly this one that we created here, demo.py. So how do we import it into test.py? We just type import, then demo, the name of the file without the extension. Then after we've imported it, we can be able to call functions that are inside this file, just as if they have been declared inside test.py. So that's what we are doing here. So we are calling demo.sit. So when we call that particular function, it's going to print this twice. A dog is now sitting. A dog is now sitting. So it's going to do it twice because the first time we import it, it's going to print this, because in this file we've called it. Then again we call it the second time here. So that's why it's printing a dog is now sitting 2 times. Okay, Python classes and methods. As we said, Python supports OOP, object-oriented programming. A class is a collection of properties and methods that are the same. Properties are simply variables that are used to describe a class. Methods are simply functions. So when you bundle them together, then we call that a class. So we use the class keyword to define a class. So the function of an instantiated class is called a method. So if you instantiate, what is instantiating? If you create an object from a class, then the functions of that particular class, they are no longer called a function but a method. So it's a little bit tricky if you haven't learned programming, but just know that instantiation is creating an object from a class, and you can create many objects from the same class and change the properties. So when you define a method, a class must carry the self keyword, which indicates the instance of the class. So this is just an example. We have demo.py here. Then we create a class called dog. So we have to use the class keyword, then the name of the class. Now inside that class, we've defined a function called sit. Then of course we use the self keyword, meaning it is a function of this particular class. Then of course look at the indentation. You see, to say that this function is inside this class, we indent it like that. Then inside the function we have the print statement. You see, we've indented it again to say that it's inside this particular function. So print a dog is now sitting. So inside that class we have that particular function. Then of course we use white space to say that that is the end of the class A. So we begin something new. So here we are creating an object. How do we create an object? The object name, which is an identifier Richard, is equals to dog. So that is how we create an object. That is how we create an object. Then after that we are printing. Print. Then we have type richard.sit. So we just want the data type of richard.sit. So we are calling this particular method using this particular object. So richard.sit. We want the data type. Give us the data type. Then we also want this print type dog.sit. So dog.sit, we're just using the class name, then the function name. So we've not instantiated. We have not instantiated. Now, when we execute this, we are going to get this as the printout, that this is a class, the data type is a class, and it's a method for richard.sit. For dog.sit, the data type is a class and it's a function because we've not instantiated. Yeah? So that is what we call, that is how we do it. That is how we do it. Okay, so again you can import demo. You can import demo because it's a module, does not have the main function, you can import it on another file and be able to call any function that is in that particular class. And when you do so, it's gonna give you this particular output. Okay, so I hope you get the difference between the method and the function. Okay, now to the most important bit of this particular topic, what we call the telnet lib. So telnet lib is a module in the standard Python library. So it is a module. It provides the telnet lib.telnet class for implementing the telnet function. So different methods in the telnet lib.telnet class are called to implement different functions. So we have several functions that are on the telnet lib.telnet class. So some of those functions are here. So for example, we have the telnet read underscore until. So this is used to read the data until a given string is encountered, or until timeout seconds have passed. So that's why you're going to give it some data here expected, or some timeout. So that is the telnet read until function. Another one that is important is telnet read all. So it's used to read until the end of file, EOF, end of file. Then we have another one, read very eager. So it's going to read everything that can be without blocking input and output. Then we have telnet write, is used to write a string to the socket. Then we have close. Telnet close is used to close a connection. So how to use the telnet lib? You have to begin by importing it. By using the from keyword, then telnet lib, then import, then telnet. So you want to import the telnet class. Then you can now be able, after you've imported this class, you can be able now to use the different functions that come with that class. For example, here we are using the telnet function that is used to create a telnet connection to a specified server. You specify the host and the port number, for example. Then you can also call, for example, the telnet read all, this one that we saw here, this one, in order to be able to read all the data until the end of file. So let's have a look at a case. Okay, so here we want to log into a device using telnet lib. So how do we do it? So a network device functions as a telnet server, and the Python telnet lib needs to be used as a telnet client to log into the device. So how do we do that? So you have the telnet client, which is your PC. We have your switch on the network, which is your telnet server. So how do we ensure that we write a Python script that can be able to log in using telnet into this particular machine, to this particular switch? So procedure number one, you configure telnet, then you verify the telnet login procedure, then you write the Python code, then you verify the results. Is the Python code able to log in to that particular device? Okay, so generally, first procedure, you have to configure connectivity so that you have connectivity between the PC and the device. You can be able to ping it. Then number two, you configure telnet. We already know how to configure telnet, so I'm not going to go through that. So you configure telnet on the device, on the switch. Okay, then you verify You verify that the configuration is working by using the telnet command. So here, remember, you are on CLI on your machine. So you're on CLI. So you type telnet, then the IP address of that particular interface. Telnet that. So if it asks you to provide the username and the password, you provide it, and it gets you into the switch. Then you now know that, oh, I'm done verifying that the telnet login procedure is working. So after you're done, you now need to write your Python code. How is it going to look like? The first thing you do, you import the telnet lib. Then you can create a variable called host. You give it that value. You create a variable called password. You give it that value. So anytime we have single quotes, it means it's a string. So even this IP address is not an integer, it's a string. So after we are done storing those two values, the IP address of the telnet server and the password that we're going to provide, we can now begin calling the telnet lib functions. So the first one we are calling here is the telnet lib.telnet that is used to log in to that particular device. So we give it the IP address of that device. Then after that, we say tn.read until. Remember, read until, it reads until it encounters a particular character. So we want it to read it until it encounters the character password. Then after that, we write the password. How do we write the password? We use tn.write. Then we give it the variable password .encode ASCII. So we want it to be sent as an ASCII, so as English characters. Then after it has been sent as an ASCII, we want to press enter. How to press enter using the code? We use this, the new line escape sequence. So /n. So it's going to press enter after entering the password. So that's what really happens. Then after that, if the password is correct, we want to use tn.read until. So we want it to read until it gets the prompt of that particular switch Huawei. So after that, it's going to show us that now we've entered into, it's going to provide us the system view of that particular switch, and when we are done, we can use tn.close to terminate the telnet session. So that's how the Python file to log into a device via telnet is going to look like. Okay, so how do we verify that that code is working? So we already did the manual verification that yes, we are able to telnet to that particular device. So you now need to run that file. On, for example, your command prompt on your PC, just like we saw earlier. Go to command prompt, then Python, then the name of that file .py. So when you do that, it's gonna log in and provide you the prompt automatically, Huawei, and now you can be able now to configure that particular device. So ladies and gentlemen, that was just a very simple example of how you can use Python to do that. A challenge that I'm giving you is to create a Python file that will be able to create VLAN 10 using telnet lib on that particular switch. So that is the challenge. Make sure you take it up. Otherwise, that is the end of this introductory topic to network automation. You can read more, you can learn more about Python on the python.org site, very important, or you can also try W3 Schools, which is a resource that I've used to learn most of the programming languages that I know. It's a very wonderful resource. Ladies and gentlemen, asanteni sana for staying put and for the support that you've given me so far. I'm excited and glad that I'm going now to record the very last topic of HCAI.com, and it's because of your awesome support and participation. Let's keep interacting. Remember to share this resource with your friends and family who are doing networking. And my call to you today is that you learn Python. If possible, please take up the HCIP.com network automation certification in order for you to have a deep dive into network programmability and automation. Otherwise, asanteni sana and God bless you. Bye bye.